everyone. I'm Dominic Williams. I'm the founder and chief scientist of the Definity Foundation. DFINITY is the largest contributor to the Internet Computer Network. And today we're going to talk about AI that runs as a smart contract on the blockchain. So that's something very different. There's a lot of blockchains for AI, tokens for AI being created today. This is the real deal. AI that actually runs on the blockchain in fully decentralized form. So for those of you that don't know, Definity Foundation is probably the blockchain industry's largest ongoing R&D operation. We're blockchain maximalists, and we're trying to drive what we call a blockchain singularity, where all compute eventually is migrated to blockchain. We were established back in 2016, and the Internet Computer now represents the product of more than 1,000 person years of R&D effort. We're a Swiss not-for-profit. Headquarters is in Zurich, and we have one of the world's largest teams of famous cryptographers, and generally the team includes a lot of kind of well-known and very brilliant cryptographers, computer scientists, engineers, and that's why we have so many research papers, and academic citations, and things like that to our name. And the team really is a mixture between early blockchain, early crypto people, and people from organizations like Google and IBM. So the big deal with the Internet Computer is that compute is now on the blockchain itself. And that's very different to what we're used to in Web3. Generally speaking, in Web3, the online service is built on traditional tech, and just the tokens and little bits of DeFi logic live on the blockchain. The Internet Computer is the first third-generation blockchain, and it brings everything onto the blockchain. So it's really blockchain playing the role of cloud. So if you go to the Internet Computer dashboard, you can find it at dashboard.internetcomputer.org. You'll see that today, the Internet Computer is processing about 330,000 Ethereum equivalent transactions a second. That's measured by looking at the low-level number of instructions processed by the virtual machine on the blockchain. And that staggering number, which far exceeds the compute of being performed on all of the other blockchains in the world taken together, reflects the fact that the Internet Computer blockchain is providing cloud-like services. It's the world's first third-generation blockchain. So, the Internet Computer supports something called canister smart contracts. It's a much more advanced evolution of traditional smart contract software. And developers can build anything with canister smart contracts. So full stack decentralization is happening today. Full stack decentralization occurs when people build things that run 100% from the blockchain. So today there are social networks running on the Internet Computer blockchain, and they're decentralized end to end. There's no traditional IT involved whatsoever. All of the data, all of the media, all of the computation, the user experience, everything lives on the blockchain. People have built order book exchanges, DEXs that look like a CeFi exchange, like Coinbase or Binance, are running fully on-chain. And the latest development is that people are using the Internet Computer blockchain to run fully decentralized AI that runs in the form of a smart contract. And that's what we're going to talk about today. But just quickly, if you're trying to understand how's this possible, how can a blockchain run AI? Well, ICP smart contracts are kind of like blockchain on steroids. They're smart contracts that are ready for anything at all. So one internet computer smart contract can store up to 400 gigabytes of data. Currently, it runs in 4 gigabytes of main memory that's dedicated to the contract. The memory is persistent. That limit's going to be raised in the next couple of months quite substantially as we're moving to a 64-bit model. They run WebAssembly bytecode. They support something called reverse gas, which means that the smart contracts pay for their own computation. So when a user interacts with a smart contract, they don't have to create a transaction, or at least they don't have to create a transaction that makes a payment for gas. The smart contracts pay for their own computation. These smart contracts run in parallel. For the technical people here, the internet computer implements something called an actor model. The smart contracts can process transactions that run over multiple blocks. So, for example, if you invoke a smart contract and it performs a long-running computation, it's not limited by the amount of computation you can do in a single block. The transaction can span multiple blocks. These smart contracts can process HTTP, which means they can serve web experiences directly to users and interact directly with users through browsers. They're fast and low cost. And when I say fast and low cost, everybody in blockchain says that their smart contracts are fast and low cost. But if you take the most efficient traditional blockchain and then you compare it to the internet computer, when we say fast and low cost, it's orders of magnitude more efficient. Orders of magnitude more efficient. These smart contracts are multi-chain capable. There's something called chain fusion technology, powered by something called chain key cryptography. You may have heard of it, that allow internet computer smart contracts to maintain balances on different blockchains, invoke their smart contracts, that kind of thing. They can make calls into Web 2. You can fully automate these smart contracts with DAOs. So no decentralization theater. You can have a DAO that has complete control over something like a social network, providing an internet community with true Web3 ownership. And finally, these smart contracts are AI capable, and that's what we're going to talk about today. So, a few days ago, I did a demo of fully decentralized AI on X. I showed a neural network running as a smart contract performing image classification. So it can look at an image and it can tell you what's in the image. And if you take the URL of my Twitter profile, scroll down, you'll see that video. It's a world first. That's the world's first demo of quite a sophisticated AI running on the blockchain itself. So we believe that AI will be the beating heart of Web3, and I invite you to dream a bit with me as we take a look at some potential ways that AI smart contracts can be used. And after running through some quick examples, I'll move to a Q&A, and if you want to, you can use Vitalik's interface for submitting questions anonymously. All right, so example number one, Ethereum safety. How can an AI smart contract improve Ethereum safety? So this is a very, very common problem. You can go to a website like Etherscan, and you can see the Solidity code behind an Ethereum smart contract. But it doesn't really help you with that question, how do I know if I should trust this smart contract? Is its Solidity code kosher? Most people aren't Solidity engineers, and most Solidity engineers don't even have time to go and audit other people's smart contracts. So you can see the Solidity code, but is it vulnerable to a reentrancy bug? Are there any backdoors that make a rug pull possible? Does it contain some malware? Might this Ethereum smart contract attack another smart contract, might it do something malicious? So AI smart contracts on the internet computer can solve this problem. They can scan the Ethereum blockchain. They can match the code hash of a smart contract to its Solidity software code. And they can verify there are no reentrancy vulnerabilities. They can verify there are no backdoors. And they can verify that there's no malware inside. And then they can produce a certification that can be displayed by a website like Etherscan. So when the user is looking at their Solidity source code for a smart contract, they can see that it's been certified by an AI audit and thereby get some additional reassurance that the smart contract is safe to use. All right, second example, autonomous KYC. So KYC is know your customer, and it's what systems have to do that allow you to interact with things like security tokens. So a future problem is that DEXs are going to want to enable degens to trade security tokens. Things like stock tokens, real-world assets, and tokenized commodities like gold. The challenge is that once you get into that field, there are a lot of regulations. And almost certainly, people, for example, that are issuing stock tokens are going to require that people buying and selling them have performed KYC. There's some kind of know your customer involved. And this is a big challenge because a DEX is meant to be decentralized, right? It's a decentralized exchange. That's what DEX stands for. And that means it should be created using smart contracts. And how on earth can a smart contract KYC somebody? How can a smart contract even interoperate with a company that performs KYC? It's a big problem. And how on earth can all these DEXs enable security tokens to be traded? Well, again, AI smart contracts provide a solution. So I mentioned that video of a demo that's on my X Twitter profile. And that was a demo of an AI smart contract performing image classification, a neural network inside a smart contract performing image classification. Well, that image classifier has been retrained and can now do face recognition. And this is a very, very cool thing because now you can have a KYC smart contract with AI inside that can, first of all, verify that somebody's a live person. It can ask somebody to, look left and right, hold 4 fingers up, that kind of thing. And then it can match that live person to an identity document like a driving license or passport. And once it's done that, it can record their identity, probably in encrypted form, and issue, for example, a Web3 credential to an authentication system like Internet Identity, which can now enable the degen to get into the DEX and trade security tokens. Nice, right? Okay. Third and last example. And I've called this an intelligent catalyst. What I'm talking about is an AI that's a kind of Delphi for your team, startup, company, government department. Obviously, it's a large language model, so without getting into the technical details, that's our objective. We want to have large language models running on the internet computer as soon as possible. And there's a lot of work optimizing the network for that task ongoing at the moment. So here we imagine an AI, we'll call it a Delphi, that works for, say, a startup company. And this AI is connected, first of all, to the company's confidential sources of information. It's probably connected to Slack and looking at messages on Slack. It's connected to Calendar. It's connected to email. It's connected to GitHub. It's connected to Jira. And it's, ingesting all of this information, and it's also talking to the team members, right? So members of the team are, giving it information like, my team is blocked by this problem. I've got this great idea to improve this thing. And, then people are interacting with this AI and they're saying things like, hey, can I get a meeting with such and such this afternoon? How near are we to closing this deal? What's our current monthly burn? There'll be permissions, right? You probably need to be the CFO to ask, what's our current monthly burn? Maybe someone in PR can say, hey, are there any good ideas for PR? So you can probably see that it's a very powerful thing. Like, these AIs are really going to drive the efficiency and effectiveness of teams and organizations forward. But there is an issue here, right? What happens if this AI gets hacked? If this AI gets hacked because it's running on traditional IT infrastructure, then the hacker is going to have access to all of that organization's most confidential information. The hacker's going to get access to the feeds. It's going to see all the Slack messages, the emails, the calendar entries, the private repos from GitHub, the tickets in Jira. It's going to see everything. The hacker will see everything. So what happens if this gets hacked? It's going to be bad. What if this stops? If it's running on a traditional server, what happens if it stops, if it breaks? Well, we can imagine, right? So 20 years ago, we all used to be really, really good at using a map to navigate the countryside or to navigate a city. We could look at a map, we could work out our route, we could memorize the route. But now, today in 2024, most of us have lost that skill. Why? Because we have sat-nav on our phone, right? We no longer have to use a map. We just look at our phone. And that's very convenient, saves us a lot of time and stress. Fantastic. But the same kind of thing's going to happen with AI. We're going to learn to lean on AI for so many things. And organizations that have this kind of Delphi AI that catalyzes their organization and acts as a nexus for information that glues everybody together, if that AI stops, that's going to really disrupt the functioning and operation of the company, team, whatever. And traditional IT is not secure. You can use firewalls and cybersecurity, but traditional IT isn't secure and it's not resilient. So what's the solution? Of course, the solution is to run the AI, which is something like a large language model, using a smart contract. And now, of course, we get past that problem. AI smart contracts are tamper-proof. They're guaranteed to run the correct code against the correct data. So they're kind of like very resistant to hacks, very secure. They're unstoppable. Blockchains guarantee that they're always going to run the code. So that's another way of saying they're highly resilient. And of course, optionally, they can be autonomous. So you can control the AI smart contract using a DAO, or if you want, make it non-updatable, right? And AI smart contracts are intelligence that's fully decentralized, and today they're only possible on the internet computer. So I invite you to join us if this is the kind of thing you're interested in. We have a network of things called ICP Hubs. They're independent organizations, and they're springing up all over the world and increasing in number all the time. So ICP Hubs are a great place to start. So here's some emails if you want to get in touch with DFINITY, and that QR code will take you to the internetcomputer.org website. Go to my Twitter if you want to see that video demo. And we have, it's changed on here, but I was going to throw it open for, I think we've got about 7 minutes for questions. So if anyone's got any questions, feel free to ask. If you put it onto that question system, the Metallic use, that works too.
We still have this live, so do you want to scroll down with me? Just like
Sure. Let's do it.
We have like limited time, but like let's see. 질문 좀 받겠습니다.
All right, okay. So When am I coming to Open Chat to do an AMA? That's a really good question. I should do that. If someone chases me and suggests a time and chases me, I'll be very happy to do it.
Go down to the
Down. Yeah. I see. Does this...
Oh, you going up. Sorry. Oh, yeah. There we go. One share. The ICP plan, maybe like this.
How does ICP plan to handle the significant computational demands of AI applications? Well, firstly, the internet computer is scalable without bounds. It's the only third generation blockchain, but it was built that way from the beginning. So, Definity is a portmanteau of decentralized and infinity. So, we've been working on this for a very long time. Internet computer is the product of more than 1,000 years of R&D effort now, and it scales. It scales properly. There's a lot of people that say that blockchain scales. Today, there's only one blockchain in the world that actually truly scales without limit. It's the internet computer. So, and it's also extremely efficient. So I think the bigger challenge for us is things like instruction limits. So I mentioned that a single transaction can span multiple blocks. When I gave that demo, you can see the video demo on X of a neural network smart contract doing image classification. Single classification was about 20 billion instructions, 20 billion WASM instructions. That's actually just doable. We're increasing instruction limits. I don't know, you can imagine them going up to 100 billion in the next few months. So some of the limitations like that are being removed from the network. We're also making it much more efficient. There's something called SIMD instructions that we like a SIMD instruction set, which is used by AI that we've determined is deterministic. So that's being added to the smart contract environment. And with a few other things, we think that within a few months, AI will run with as much as 10x the efficiency on the internet computer that it does today. So we're addressing the challenge of AI compute both by increasing limits and by making the execution environment more efficient as pertains to running AI computation. But the network scales without limits, so you can run any number of AIs. If people want to run AI, then eventually it's the networks. The network maintains a buffer capacity, and the node providers who run these things called node machines. It runs on a sovereign network, and there's a community of about 125 companies around the world that run this special node hardware. And as the network starts running out of capacity, they'll just add more machines. Anyone can become a node provider, by the way. It's a permissionless network. So, and the other limit with respect to AI is actually main memory. So currently, the internet computer uses 32-bit WASM, 32-bit WebAssembly virtual machine, and that means that each actor smart contract, each canister smart contract, only has 4 gigabytes of main memory, persistent memory pages, and that limits the size of the models. So if you've got a large language model, you're really getting into the several billion parameters. So you roughly need double the memory. So if you've got a neural network that has like 2 billion parameters, well, you're going to probably need 4 gig to run it. That's the limit currently. But the good news is in 1 to 2 months, we're anticipating the internet computer will move to 64-bit WASM. And this will enable us to increase the per smart contract main memory limit enormously. And our target is to have large language models running on the internet computer as smart contracts as soon as possible.
All right. I think we're good. Yeah.
We're good.
All right. Thank you so much.
Thank you very much. Thanks for having me, Erica. Thanks.
Yeah. It's okay.